In this video, we're going to restore the power supply and the analog board for the Mac SE30 project. While the power supply and the analog board for the Mac SE30 are currently working, they have some issues that are likely to cause a failure in the future. I'm especially concerned about the flyback transformer on the analog board. This can cause damage to other components if it fails. All of the insulation has been removed, so it could have some high voltage arcing issues. I'm also concerned about the reliability of electrolytic capacitors made during the era in which this Mac was made. So let's get them both recapped, and we'll apply some high voltage corona dope to the flyback transformer to give it some insulation. I'm going to try something new for you in this video. I'm always trying to find a balance between making a video for someone who's watching for the entertainment and for somebody who's trying to do this and work along with me. Generally, I edit a rough draft and then edit that down to a shorter video. So for this video, I'm going to try publishing the longer rough cut as an option that you can watch. It'll be unlisted, but the link is in the description below. Since we now need to disconnect and remove the CRT, it's critical that it be done safely. The glass envelope of the CRT is coated on the inside and outside to create a massive capacitor with glass in between as the dielectric. The inner coating is the anode, while the outer coating is connected to ground. This can remain charged for some time after the machine has been turned off and unplugged, especially if the bleed resistor that's built into the flyback transformer has failed. This can hold tens of thousands of volts, so at best, you're going to get the shock of your life, and at worst, you could lose it. This machine has a fairly small CRT with an anode voltage of only about 13,000 volts. I mentioned in an earlier video in this series that I was going to get a proper discharge tool for the CRT. Unfortunately, I was unable to find one for less than about $150, and I did find information that indicated that this CRT is small enough to safely discharge with a homemade tool. To do so, I took this old screwdriver that has a well-insulated handle. I then attached a heavy-duty clip lead, making sure there was a good connection between the shaft and the wire. I was having trouble getting that good connection, so I cut a couple slots in the shaft of the screwdriver just to get a better physical connection. For good measure, I also added a layer of heat shrink tubing. I will include a link in the description to an awesome video by Branchus Creations that specifically deals with discharging this era of CRT. I prefer to leave anything with a CRT to sit unplugged for a few hours at least, and preferably overnight. If you don't have time to do that, make sure it's discharged. But even if you do, don't trust it. Things can happen, and these things can hold a voltage for a long time if things have failed. Because things and stuff. It's important to connect the clip lead to the ground lug when discharging the CRT to prevent damage to other boards. It's also really important, do not wear an anti-static strap while you're discharging a CRT. The last thing that you need is a better connection to ground. So next, with one hand in your pocket or behind your back, you just slip the screwdriver tip under the anode cap until you touch the contacts at the center. If the CRT has a charge left, then there will be a pop and a little bit of a spark. If there's no spark, then hold the screwdriver against the contact for a few seconds while wiggling it around just to make sure you've got good contact. After the CRT is discharged, you can safely remove the anode cap and then remove the analog board and power supply, as we did in the first video in this series. Once I had removed the power supply from the analog board, I did a quick sketch of the capacitor locations, values, and polarity. Now let's get this board cleared of all the old capacitors that are no longer needed. There's one cap that I cannot see the value on. I'm pretty sure it's a 470 microfarad. So I'll remove the caps around it first so I can see its value just to be sure. So a soldering gun, desoldering gun is awesome to have, but I've been doing this since the late 80s and I've owned a desoldering gun for about the last year. It's nice, it's handy. You can definitely do without it. If you need to, you can use a solder put or a solder sucker, as I like to call them. So if I don't call it a solder put, well, I suck. What can I say? But with the desoldering gun, it kind of sucks when the pins are bent like this because you kind of need to get the pin into the hole. Give it a second to melt and then suck it. Suck it. this cap is being held in by hot glue. I say, I thought it should be loose. We'll just work it loose here. Not a fan of the hot glue thing. I get why they do it, and it makes it hard to replace them later. I do want to apologize how long it took me to get to this video. It's just a matter of I messed up my wrist and I had a lot of trouble editing. I kind of developed a new style of shoot a little bit, carefully plan so there's not too much footage, get it in the editor and initially set up, and then shoot another little bit. But for this video, I already had like 4 hours of footage in the editor off of 2 different cameras. So the time it was going to take me to do the editing was just more than my wrist could handle all at once. So I've been doing it in little bits at a time. And now that the stuff I had already in there is taken care of, now I can finish up getting this out. This is being a bit stubborn. I don't want to lift any traces. You gotta remember, this is only a single-sided board. I'm gonna try just touching it with an iron while I'm pulling on it. All right, those are definitely loose. It's just this damn wad of hot glue. There we go. That is out of there. Yeah, out of there. So let's glue off of here. I like that there's a big wad of glue on this inductor. It's going to get in the way with my new cap if it's any bigger. So as I do this, the last cap I'm going to do is the big one here. And the reason I'm doing that one last is it's a very unusual cap. In fact, until I started looking into these Macs, I did not even know this is a thing. But that's a non-polaric electrolytic cap. So it's an electrolytic cap, but it doesn't have a polarity. Funny enough, there is a polarity marked on the board, so the replacement, because they don't make that type of a capacitor anymore, in this case I bought a kit, but the replacement is not an electrolytic cap. I believe it's a foil. I'll fix the audio in a minute, but so this cap will have to fit with this type of a lead spacing, so I'm going to have to bend these something like that to fit them in. And I have made a sheet where I just hand drew the board real quick and dirty, marked the position of every cap and the polarity. So the one I just took off is there, plus on the positives at the bottom, 1000 microfarads, 16 volts. You can also do it this way. It uses a bit of toner, but what I've done here is I've taken a picture of the power supply. This is the other board that we'll do next. And then I've set the opacity in a graphics program real low, like 25%. So I just basically print a watermark of the board on a piece of paper. It doesn't, if it's full brightness, it's just kind of hard to see your writing on it, and it wastes a ton of toner. But this way I've got the watermark, and then I go back and I just hand draw the caps. And this board had just a boatload over here. As you can see, there's just a ton of packed in caps there. In fact, I haven't even got a value for this one down in here yet, but we'll worry about that when we get to the power supply. I'm running the desoldering gun at about 350 degrees Celsius. I'm running the soldering iron at about 375. I want enough heat to get these caps melted off of here quickly, but not so much heat that I'm going to lift a trace. Hot glue. What a mess. That one came right off, and so did that one. Okay, here's C7. So it's these two here. One's toward the middle of the board can be a little harder to spot where the leads are. That. Hard to tell where that's going to leave. It's right here. In the event that you accidentally unsolder the wrong spot, it is not a big deal just to resolder it. And sometimes it's kind of hard to tell where you're going for. All right, now we got some axials. So, got these guys. And since my soldering iron is sitting here hot, I just got to remember to hit it with a little bit of solder every once in a while to keep it tinned. Don't want to burn the tips. Take your time, make sure you're getting the right spot. Not a big deal, but see, I tell you it's not a big deal, but let's face it, I get annoyed as hell with myself if I do desolder the wrong spot. Did that on one of the Commodore 64 videos. Last one is this one up in the cage, being all so sneaky and hiding up in there. When you're done using the soldering gun, make sure you run it for a while just to suck anything through. And this guy. All right, now another issue we have to deal with is, as we looked at in the other video, this pin has got a cold solder joint, which, you know, cold solder joint makes it get hot, if that makes any sense. So I am going to go ahead and desolder that connector and then resolder it, just rather than just reflowing. This solder is pretty burnt here. Before I do that, I'm going to need to add more solder. I love solder. Where's the sod and solder? I don't know if you can tell, but I put the iron against the pad and the pin, and then I put the solder on the opposite side so that the solder is getting melted by the work, not the iron. The iron puts heat into the work, and then the work melts the solder. These other three are probably just fine. And then it's slippery. The pins are too big to fit through the hole of the gun. See if I can burn myself. Alright, so now I've removed most of the solder from that connector. Next, I am going to put a bit of flux on these. And that pin did not want to take solder. It was quite a few tries there before it started taking it. This flux will just help the solder in here. Soldering iron. I've been playing with this tip. It's not one I've ever used before, but I kind of like. I like the shape of it. That little hook, I can snag it around the work, get a lot of heat to it, even better than a chisel. Then there's some heavy pads, so it takes a lot more heat than I'm used to. Especially if you're working on a ground plane, it's going to take a while. The good thing is when you're working on a tracer, it's burnt like this, there's a lot of risk of lifting it. But if you find yourself working on a ground plane or something, you don't have to worry too much, because it's pretty hard to lift a ground plane. It's just such a big mass of solder. And this thing is ugly as sin. I don't think it really matters a whole lot, but you can just see how ugly that is. There's like a hole in the solder. That's just holding this and grounding this cage around the flyback transformer, so it's not a huge deal. But it lacks the prettiness I require. So I'm just reflowing the solder and then just adding a little fresh solder to it, making sure that the part is being properly attached. There's afterwards. I haven't cleaned the flux off yet. That'll come after I solder on all the parts. So the next part I'm going to do, now that I've got all of the caps off here except for the non-polaric one, I'm going to take some solder braid. So I'm just going to use some solder braid and soldering iron. Snip off the used end. Now what we're going to do is we're just going to take the soldering iron, heat up the braid on the work, and just run it over the pad. Be careful, the wick is designed to hold heat, so it will run up this right into your finger. So just kind of moving the wick over the pads until they look nice and clean. You can see the wick getting solder in it, so that tells you it's doing its thing. If you saw the mainboard video, that was my first real experience with SMD, but this is through hole. That's definitely my bailiwick. This is what I'm used to. Now this little tip doesn't work as well for this, I'm noticing. Just a chisel tip lets you slide and hold it a little better. I have to kind of hook the point of this tip into the wick before I can use the tip to move the wick. Oh, this is all looking nice and pretty. That one And look at the pads, they look nice and clean and ready to accept new parts. Now I'm going to go ahead and pull off this last cap. Because it's unusual, I saved it for last, so it's just a habit of mine. There's no reason you have to do that. And if you've done this multiple times, I wouldn't bother. I just like to get everything ready and then deal with the potential problem child or just something that's unusual all at once. So now I can desolder this cap. I can desolder this cap, get it off the board, clean up the pads, and put the new one right on. So if you ever have a question like on the power supply, I've got that one cap that I can't identify. What I was saying is I've removed all the caps off the board except for the one that's unusual. This is the non-polaric cap. Then once that cap, all the other caps are ready to go, I'll get this one off and immediately replace it. That way the one that's unusual that may cause issues just because I'm not familiar with it can get taken care of all at once. All the rest I'm perfectly happy to do them in a batch. If you're doing this for the first time, feel free to just do one cap at a time. Look at its position, take it off, put the replacement on exactly the same way, and then move on to the next one. There's nothing wrong with that. I did that a lot of times. And it'd probably be better off doing it that way when I'm shooting a video because the video distracts me. It makes it a little harder to focus on what I'm doing. Or at least this part of what I'm doing. It's the frickin' video that gets my attention. Cap is out and the replacement all right, so what I'm doing, so I've twisted it a little bit because if I put it in flat it might get in the way of that connector and I don't want that to happen. Bend the leads back just a tiny bit in each direction. They don't need to be bent over. I see that a lot and it makes it hard to take them out later. So just a little bit of a bend to hold them in place. Grab your iron, apply some heat. Bazinga. You want a nice sharp pair of end cutters that are flush, that don't have a bevel on both sides, just for snipping them off. And when you look at the solder joint, you should just have, and that one looks cold in the camera. It's nice and shiny. It's just the way the light's playing on it. And then when you snip the leads, just put your finger on the lead. Otherwise, it can go flying and you never know where it's going to go, including into your eye. All right, so now I'm going to put all the new caps on. And again, this is a kit that I bought, but you can source them yourself. When I do the video on the Osborne Executive, I plan to do a segment on how to source capacitors, how to order them. In this case, though, I'm just using a kit for from Console 5. Their kits seem really nice. All right, so I'm just going to bring up my checklist here. I'm going to mark off the caps as I put them on. That one's done. 1,000 microfarad, 16 volts. Now, here's a great example. We're replacing a 1,000 microfarad, 16 volt cap with a 1,000 microfarad, 25 volt cap. If you're going from 16 to 25, as long as you're going to a higher voltage and you're not going crazy, you put a 400 volt cap in, you could have issues. But going from 16 to 25 volts is fine. That is the point at which the capacitor would fail or could fail from too much voltage, so you don't need to worry. But you can get into some more esoteric issues with, you know, say, like I said, a 400 volt cap. There's some things like ESR that you can have issues with. So now this one, of course my drawing is drawn for the top of the board. The cap is marked on the negative, unlike the main board where they were marked on the positive and I put them in the wrong way. So then this is the one we just replaced. So modern capacitor technology tends to be smaller than the old stuff. So don't sweat it if the cap looks a lot smaller. That is just fine and dandy. So 100 microfarad, 25 volts. Goes right there. So this case, the caps are marked where their positive lead goes, which is great, but don't trust it. Mark it and get it before you start. If you looked at one of my Commodore 64 videos, you'll see where the mark had been worn away to the point where it looked like a minus. I have also seen boards where it's literally marked wrong. Let's see here. I think I am done with the soldering gun, so I am going to tin the tip. Run it for a minute. And give it a rest. Hey, quiet. Ooh. All right, so this is all four of the 100 microfarad volt, 25 volt caps. And if you have trouble where you can't get the solder to melt, try using some flux. Oh, I got a lifted pad, damn it. All right. Crap. Manage that. So I'm going to say that probably what happened here is the pad was overhanging the hole, and as the cap went through, it lifted it up. See right here. I'm going to go ahead and get the lead up through it. The pad's not detached, so I'm going to go ahead and drop it down, solder it. So what I did is I exposed part of the trace. It was still firmly attached to the board. I cut the lead a little long, ran it along the trace, and then soldered it down. You can also run a bodge wire from there. As it was, it probably would have worked fine, but I'm not in the habit of just leaving loose pads holding components. Moving the components around and the like can break the trace, or you could knock the trace loose. All right, so that was that one, that one, that one, and that one. So 10 microfarad, 160 goes right next to it. So that way. $220 microfarad, 16 volts. It goes that way. Big round plate. Okay. that was that one. Working up inside the cage here can be a little tricky. I've got the positive the right way. One other thing that's kind of nice on caps is that the positive lead is usually longer than the negative. So when you're putting it in, you can get the positive lead into its hole and then adjust the cap to move the negative lead to line up with the other hole. Because you got to get it in the right holes. $4,700 microfarad, 16 volts. Let's tape on these things. It does go that way. Now this is a big ground plane, so this is going to be a bit of a bear to solder, I suspect. Well, maybe not. Not too bad at all. Okay. So that one there is 33 microfarad, 16 volts, which is that one. Negative goes towards the can. And last but not least, $22 microfarad, 50 volts. Positive goes towards the fan. Negative towards the cap we just put in. All right, last two. Good thing, I'm almost out of solder. Not that I don't have more, but you know. Another real heavy ground plane. Watching that temperature on my iron drop precipitously. Might have probably wanted to turn it up a bit just to have a little more stored heat. I'm going to throw a little bit of flux on this other heavy ground plane. I'm going with the light flux. There are some other options, including that or a paste. That iron needs tinned. If your tip of your iron starts looking brown at all, just tin it. Don't wait. I was so bad with my soldering iron tips back in the day. I would sand the damn things, and then you take the coating off, and it's just like, after that, it was just constant maintenance. So I learned the hard way. Take care of your tips. And like I said, I lifted one pad. I had a minor mishap, and I'm leaving that in the video just so you know it's not the end of the world. Stuff happens now and then. There it is. All capped and happy. Now I just gotta do one last thing. You know, I went to school for electrical engineering tech, and not one time did they ever talk about cleaning your flux, cleaning your flux residue off the board. So when I started getting back into it and watching videos, and everybody made a big deal about it, I was like, yeah, I could see that, and kind of satisfying to see the board get properly cleaned. Of course, this board was already cleaned, so there it is. That alcohol will evaporate off just fine, and we are done with the analog board. All right, so the next step, what I want to do is the flyback transformer on this is completely devoid of any kind of protection from from corona arcing, which I understand can be an issue. I believe I showed it in another video. If not, I'll get a shot of it. But the other analog board, the Flyback, literally has arcing, and you can see little tracks around the top of the transformer. So the Flyback here should have some insulation on here to protect it from arcing from the inside. So what we're going to do is we're going to start with a little bit of alcohol, and I apologize in advance for any noises. I'm going to be using something that's pretty nasty, so kind of try to avoid stuff like that. So we have all the windows and doors open for good ventilation in here. But to start with, use a little isopropyl alcohol and just cleaning the top of this Flyback really well, just to make sure that the stuff we're putting on sticks. And I think I've cleaned this in the past, but so now that needs to dry really well. The Q-tip came out reasonably clean. And what we're going to be using today is called Super Corona Dope. So we're going to be using some dope, man. Dope! And this stuff comes with more warnings than just about anything I've ever used. Harmful if inhaled, looked at. Even if you have some next door, it can kill you. Okay, maybe not quite that bad, but it sure feels that way. Enough so that I'm not even comfortable recommending this. I don't think I will put a link to this in the description below. It's just, if you need it, you can find it. Its purpose, though, is to act as a super insulator to protect things from leakage, that is, current leakage. So motor windings and the like. So what I'm going to do is I'm going to put on a pair of gloves, and I'm going to put on a pair of glasses. All right. And then I have a disposable brush. It doesn't say anything about how to clean the brush and otherwise, so I'm just going to use an acid brush. We'll go ahead and open this up. A little bit of this. We'll just paint the whole top of this. And this smells exactly like model airplane dope when I was a kid, which is kind of hilarious. Okay. Now that that is on there, we'll close this back up. So we have a nice coating of the stuff. I am going to take this board and I'm going to put it out in the garage so that I'm not breathing these fumes to dry. Also going to wrap this up and throw it away in the trash can. Now, for this one, I have a cheat sheet here. I showed it to you guys earlier, but I'm going to need to identify this one cap right here. So that would be this one here. It's tucked in between these two caps. I just can't see what it is. So I think my strategy will be to take out these 4 caps around it, identify what it is, and then continue. I don't like to, let's just put it this way. I'll get off on a tangent and I'll just start yanking out caps and then not realize which one it is. I would probably be able to figure it out once I put everything else back in, but you know, better safe than sorry. And as you can see, in the olden days, they weren't real big on cleaning the flux off these boards. That's just, that's like that from the factory, Flux City. This boy's had a lot of caffeine today. That one's coming right off, fell right out. A lot of my friends would probably tell you how much I am not a Sony fan. I've just been hosed by them too many times in the past, and that cap is leaking a little tiny bit. See some signs of leaking around the edges. But I have to say, this is a very nicely designed board. You can see wherever there's a cap, there is actually a marking on the board to indicate that it's a capacitor there. On the back side of the board, it makes desoldering way easier because you can actually know what component you're removing. God, it would be a dream if that Amiga 3000 desolders as easily as this thing does, because this is fantastic. Parts are just falling out of here. Literally just falling off the board. Way to go. I know my head's probably getting in the way, but I gotta see what I'm doing. All right, so this last cap has huge contacts. They're absolutely huge. So that C162, which is a very large cap. So I'm going to have to get a lot of heat on those big ground planes to get those off of there. So I am turning the soldering up to 425 Celsius. So I'm getting a lot of heat on the pad from one side and sucking from the other. That's about all I'm going to get that way. Then I am going to use some soldering braid. Now, if you're working on something like this and it's giving you a hard time, if you can just get one leg loose so that it's free, then you can just apply some heat to the other leg while gently moving the part until it comes loose. This is a rather clumsy way to do this. I don't recommend it. It's all just because of the camera. So, but there you have it. It is out of there. I finished just cleaning up these pads. And last night when I was doing the analog board, I made a mental note to change to a chisel tip on the soldering iron, but apparently that note got lost in the shuffle. All right, the caps are all off. Now, one thing I like to do in something like this is any large areas, I'll go ahead and reflow it. And my habit is to do it after I've removed any parts that need removed, because I'm just looking at the board while I'm doing it, so I might notice things I want to take care of. But I prefer to do the reflowing before I put the new parts on, because if I don't, I'll get the new parts on, go done, and forget to do it. So just heat it up good, add a little tiny bit of fresh solder. The flux in the solder will just help it flow better and make sure there's a good electrical connection. You can also add a little bit of flux, but this board is just, it's absolutely flowing beautifully. For anything that looks like it may not have a great connection, that one's definitely cracked. Okay, so again, using a cap kit. Got a lot of light coming in there, don't I? These are all the new caps that need to go on. And one thing that I know is that you can see, looking at the old cap and the replacement, that the positioning of the pins is different. So this cap is not going to fit in this space. So I have a couple options. One would be to just jumper it, but then the cap wouldn't be physically attached to the board as well. The other option is going to be to drill it, which is what I am going to opt to do. So let's try that first. And of course, in order to do that, the glass has got to go on. And I'm going to try something. I don't know how well this is going to work. I'm going to try using a knurling bit on the Dremel instead of a drill bit. Bad idea? Hey, maybe, but we're about to find out, and then you can learn from my mistake if it's a problem. And for once, it kind of worked the way I imagined. It allowed me to remount that hole without making a huge mess. And without a drill bit that, I don't know, drill bits just don't seem to like to cooperate. Set that to match. Come through from this side. That couldn't fit any better if you ask me. That looks perfect. So now, turn on the soldering iron. And I am going to grab a little bit of alcohol and clean up this board. Put the new cap in, negative to negative, positive to positive, goes just like that. Okay, so I added a little bit of flux, turned up the iron heat. There's a big ground plane we're up against here, so we're just going to need some extra heat. We've got our cheat sheet here. And the big one's in there. And I need 100 microfarad, 16 volt. All right, so I thought I was missing a couple of caps. So these are the original old ones. They are, I was reading them as 0.7 microfarads because of the spacing. They're 4.7 microfarads. So as you can see, there's a pretty dramatic difference in size, even though the voltage on the new cap is actually 400 volts instead of 350, which is not a problem. It's fine to go a little over, just don't go under. You can put them all in if you want. I just, when I get too many, I've got all these leads getting in my way, so I like to just knock them out real quick. .47 microfarad, 25 volts. Microfarad, 50 volt, another first time grab. You guys can work that way all the time. You know, since these boards are marked with capacitor numbers, like that one I just put in was C265, probably wouldn't hurt to add that onto these as well, so you don't have to double check to make sure you're putting in the right part. All right, 22 microfarad, 25 volts. If there's any kind of a package I hate the most, it's these stupid masking tape style ones. All right, looking good. Now, I want the 470/16. I'll zoom to the top. The 470/16. Got the right lead spacing for once. That's nice. Got that one, that one, that one, and that one. Wrong freaking spot. All right, there we go. We are recapped. This one, it's a lot of weight to be hanging off of those two little leads. It doesn't have the big solid leads of the others, so I may not get this on camera, but I will get out my hot glue gun and put a couple blobs along the edge of this cap just to support it. Other than that, we are good to go. Just one step left, and that's to clean up our mess. I've been kind of looking forward to this because this thing came out of the box just covered in disgusting amounts of flux residue. Normally this would be in a spray bottle, just a little bit of alcohol. I wouldn't mind hitting this with something a little stiffer, but I don't want to risk removing the resist, the green resist that protects the traces and prevents solder from sticking to them. So now that the power supply is recapped, we'll put it all back together. So I added a thin film of thermal paste onto each of the thermal pads just to make sure we get good heat conduction. And now that everything's back together, we need to check the voltages. Go ahead and plug it in, turn it on, hooked up the meter. And for the meter, I'm just adjusting off of the 5 volts. And the 5 volt line is, I believe, the orange wire with the black wires being the ground. Now when I checked it, I found it was at over 5.4 volts, and that sounds really high. I mean, that's enough to fry chips. But the fact is, it's probably fine at that because this power supply has no load on it right now. I am a little uncomfortable with that. I'm going to drop it down to around 5.3 volts by adjusting the trim pot that's on the board using a non-conductive screwdriver. Do not use a metal screwdriver to do this. Took a little bit of tweaking, but I finally got it, and at 5.3 volts, I suspect when we have everything running with a load on it, we're going to be at about 4.9, 4.95, somewhere in there, which is fine. As long as we're above 4.5 volts, this machine should run just fine. Alright, so those were the last pieces that needed restoration, so everything's ready to go together in the next video. I hope you enjoyed this video, and here's another one you might like.